Okay, this is Unit 12, Lesson 4. This is talking about the effects of pyramid dimension, area, and volume changes. Also included in this is some more work on units conversion. Okay, so once again, let me remind you that if you have any idea that you might need to ask a question, get yourself a piece of paper, pen or pencil so that you can record what you're wanting to ask. Be prepared just to pause the video and write your question down. We'll be glad to address it before you start any work with it tomorrow. Okay, so let's take a look and see. The definitions and such. As with prisms or any other three-dimensional object, any volume calculation of a pyramid involves the multiplication of three dimensions. If a new 3D object is produced by adjusting the scale factors, scale factor 1, scale factor 2, and scale factor 3 of those three dimensions, then you simply find the scale factor by which the volume changes is the product of those dimension scale factors. So that means you multiply them all together like this for the volume. So the scale factor of the volume will change by scale factor 1 times scale factor 2 times scale factor 3. Okay, if all three dimensions change by the same scale factor, or SF, then SF sub V, or the scale factor of the volume, is simply the scale factor to the third power. Alright, so that brings us to this, that if you have a 3D object produced by adjusting the scale factor of all three dimensions, then the scale factor by which the surface area changes is the product of those dimension scale factors. Okay, so this would mean that the surface area of or the scale factor of the area would equal to the scale factor squared. So whatever your scale factor becomes, that's what you're going to do. But you make sure that you go to the base scale factor, which is like if it's increased by 3, then what you do is you square that, which gives you 9. You do not cube it and then square it. Okay, you simply square the scale factor, so you always need to find the base scale factor. Okay, so let's take a look at example 1 and 2. It says Pharaoh Khufu was not satisfied with his first pyramid having a volume of 3,600 cubic meters and decided to have another built in which all the dimensions were twice the original dimensions. So our scale factor is 2 because it says everything's going to be twice. Okay, so what will be the volume of the new pyramid? In this case, all of them are changing by a factor of 2, so this means that to get our scale factor, we're simply going to take 2 to the third power, which is where that comes from right here. Okay, so the volume of the new pyramid is going to equal the volume of the old pyramid times 2 to the third power, which gives us volume new is equal to 3,600, which is what the original one was, times 8, which is 2 to the third power. That gives us the new volume is going to be 28,800 cubic meters. Okay, example 2 says by what factor will the total surface area change of the surface area of the pyramid change? Okay, so once again it changed by a factor of 2, so the scale factor is equal to 2. That's our base scale factor. So we've got to square that to get the surface or the scale factor of the area, which is going to be 2 squared, comes up to 4 times. Okay. So the new surface area will be 4 times whatever the original surface area was. Okay, let's go on to example 3. Okay, this time we have a pyramid having a volume of 200 cubic inches, has its dimensions all halved. So this means that our scale factor is 1/2, but it is uniform all the way through. So this means we can take a little bit of the shortcut. So what will be the new volume in cubic centimeters? So this means we're going to have to do some units conversion also, because notice that we were originally given cubic inches and now we need to convert that to cubic centimeters. And they're telling us that 1 inch equals 2.54 centimeters. Okay, so the first thing is scale factor is equal to 1/2. So the scale factor of the volume is going to be 1/2 to the third power, which equals 1/8. Okay, so this means the new volume is equal to the original volume times the scale factor of the volume is equal to 200 times 1/8 gives us 25 cubic inches. Okay, so let's convert that to cubic centimeters. So this gives us 25 cubic inches over 1 times the 2.54 centimeters over 1 inch, and all that is cubed. So this gives us an equivalent expression of 25 cubic inches over 1 times 2.54 to the third power cubic centimeters over 1 cubic inch, which is equal to the 25 times 2.54 cubed centimeters cubed, which is approximately 409.68 cubic centimeters. Okay, it's very important to follow the arrows here so that you see where each step leads you. Okay, let's look at example 4. Okay, example 4 says a rectangular pyramid has a base area A of B and a height of H. Which of the following represents the volume of a new pyramid in which the dimensions have all been increased by a factor of 3? Okay, so once again, what the whole thing comes down to is let me get back to this. They're giving us, this is a multiple choice question. They gave us 5 choices here, so we have to figure out which one is correct. So would the volume of the new one simply be the area of the base times the height? Would it be 1/3 of the area of the base times the height? Would it be 3 times the area of the base times the height? Or would it be 9 times the area of the base times the height? Or 27 times the area of the base times the height? Here's what we do. We go back to our formula, which says that the volume of the new one is equal to the volume of the original one times the scale factor of the volume. Since we're told that it increases by 3, the scale factor of the volume is going to be 3 cubed, okay, because it was uniform throughout. So this becomes 1/3 of the area of the base times the height, and all of that's multiplied by 3 cubed, which gives us 27. So 27 times the 1 over the 3 gives us 27 over 3, and we still have the variables area of the base times the height. Okay, 27 over 3 reduces to 9 times the area of the base times the height, okay, which is answer choice D. So this means that the answer choice that we should pick here would be D. Okay, example 5. If the total surface areas of 2 similar pyramids are 102 square meters and 1632 square meters, what is the dimension scale factor of the smaller to the larger pyramid? What is the corresponding volume scale factor of the smaller pyramid to the larger one? So the first thing he wants to do is to find the base scale factor, and then we're going to use that to tell what we would have to do to get the volume. Okay? So what we're going to do, since we know the areas, this means that we know the surface areas compared to each other. So we're going to look at this. So we get this for the areas, gives us the scale factor of the area is 102 to 1632. When we divide that out, we get 1 over 16. Okay, remember this is the base scale factor squared. So that means that to get the dimensions scale factor, what we have to do is take the square root of this. So 1 over 16, square root of that gives us 1 over 4. So the base scale factor is 1 over 4. So now we're ready to find the volume scale factor, which is simply the base scale factor, 1 over 4 raised to the third power, which we find is 1 over 64. So if we knew what the original volume was, we could divide that by 64, and that would tell us what the small one had. Okay, this concludes lesson 4 of unit 12. So once again, if you've written down any questions, be sure you bring them to class. We'll discuss them before we start any work. Talk to you tomorrow. Y'all have a great rest of the day. Thank you. Goodbye.